Hi everybody. Today I'm going to take the irrational number stuff and show you how to apply it in geometry. This is an 8th grade standard about what's called the Pythagorean Theorem. And it has to do with triangles, but only with right triangles, triangles with a right angle. In any right triangle, of course in any triangle you have three sides, but in a right triangle we call the two sides that come together to make this right angle the legs, okay? And we can call that A and that B. And then this third side, the longest of the three sides, it's called the hypotenuse, and it's the side that's across from the right angle. And I'm going to make a different video where I sort of show you an explanation for this, but the Pythagorean theorem says that if I take this length, raise it to the second power, and I add it to this length to the second power, that would equal the third length, c, to the second power. A squared plus b squared equals c squared. And I'm going to do two examples and show you how to apply this. Here's the first one. Pause and copy it down. But here I have a triangle, and I have one side that's 5 centimeters and another side that's 12 centimeters, and I'm looking for this third side. And the third side I'm looking for is the hypotenuse. All right, so since I'm looking for the hypotenuse, I'm going to set this up using a squared plus b squared equals c squared. But I know the length of a, that's 5 squared. And I know the length of b, that's 12, so 12 squared. And that equals, c is this thing that I don't know, so I'm going to use x to represent that. So I've substituted in each value. This is pretty simple. I'm just going to carry out the exponent. So 5 to the second power is 25. And 12 to the second power is 144, and that would equal x to the second power, whatever that is. 25 and 144 is 169, and that would equal x to the second power. So that does not mean that this length is 169 units. It means that that length squared is 169 units. So the last thing that I have to do is undo that second power by taking the square root. And I know that you all know that it's plus or minus 13, but we don't care about the negative value. We only, like in a length, we would only care about the positive value. So that means that this length has to be 13 centimeters exactly. Okay, so that's a simple use of the Pythagorean theorem. Let's do one more example. See this one? It says find y. So the difference between example 1 and example 2 is that in example 1 we were finding the hypotenuse. But look, I'm given the hypotenuse in this example. I need to find one of the legs. So let's pretend if I start with a squared plus b squared equals c squared. If I know the length of a is 5, I'll substitute 5 squared, but I do not know the length of b, so that's what I'm looking for. So I'll leave that as a y, and that equals 8 squared. So now I'm going to carry out the exponents again. 5 squared is 25. I do not know y, and 8 squared is 64. The difference here is I'm solving this like an algebra problem, so I'm going to subtract 25 from each side to isolate the y squared. And 64 take away 25 is 44, 39. So now I need to take the square root of y to find the square root of 39. That would be the length of y. And guess what? I don't know the square root of 39 off the top of my head. I do know, however, that it's somewhere between 36 and 49. Okay, so it means, let's see here, that's 3 out of a total of, what is that, 13? So it's 6 and 3/13 or so. So let's just quickly figure out what is 3 divided by 13. 13 goes into 30 twice with 4 left over. It goes into 43 times with 1 left over. And so we can call that 6.23 inches. Maybe 6.2 inches is better. That'd be about what that length is.